Good afternoon. I think it's time for us to get started. So welcome to this afternoon's session, Reinvent Government in a Data Intelligence Era. This is split. I'm going to do approximately a 20-minute presentation, and then I'm going to pass it over to Asim to lead a fireside chat. Get the clicker here. And I do have a couple of forward-looking statements before I start. There are some features in the presentation that are not available in every region in which Databricks is deployed. As a government presentation, I see some smiles here, but just wanted to point out that there may be some roadmap features discussed in the presentation. My name is Eric Popowich. I'm a senior solutions architect. I've been with Databricks for approximately 4 years. I primarily support customers in the federal civilian territory. Prior to this, I was in a similar role at Oracle for 6 years, supporting the Department of Defense. I've worked at Splunk in a similar role, supporting the Department of Defense for 6 years. And if anyone can remember Vignette, I was there for 9 years, building a lot of the early federal portals. In the presentation today, we're ambitiously going to discuss how we can reinvent the way government does data and AI with the Databricks data intelligence platform, which I think is pretty topical because for at least the last couple of administrations, this has been a top government priority. With the IT Modernization Act, there was a lot of emphasis on moving from on-prem applications to the cloud to improve scalability, performance, and have better cost models. Federal data strategy was an attempt to improve the federation of data and make it more accessible. More recently, the AI executive order has made an attempt to accelerate the adoption of AI within public sector. And then most recently, within the last 3 months with the current administration, right, very ambitious, stopping waste, fraud, and abuse by eliminating information silos executive order. So we're going to try and touch on parts of all 4 of these in this presentation. And I think we all agree that government struggles with both data as well as AI. If we look at all of the government services listed on the left side of the screen, they typically have the same architecture. There's a transactional system which is responsible for receiving service requests or benefit requests or payments. There's an adjudication process to deliver that service or mission. And then that data is typically moved to an entirely different analytics environment. There may be some historical analytics, maybe compliance analytics, fraud analytics run on the data. And then that data is transitioned potentially to a lake where there may be, in some agencies, AI performed to do more predictive analytics. Regardless, when we look at these individual application silos, typically, at a minimum, the data estate is fragmented. So the transactional environment is separate from the analytical environment. And then in the case where there's a lake, typically there's multiple copies of data that are transitioned to the lake. And then we look at the agency as a whole, it can usually look much worse because you can have every application having its own data estate, making it very difficult to perform agency-wide analytics, very difficult to understand the security posture of the entire environment, and resulting in many different copies of the data. So what we're going to propose, as I alluded to earlier, was reinventing this architecture that supports both data and AI with the data intelligence platform. There's 2 core components that we're going to discuss. The first is obviously the data lakehouse. So this is going to be a cloud-based architecture that provides an open, unified foundation for all of your data. And then talk about how we're integrating in generative AI to improve the efficiency in which data teams can access accurate data and build predictive analytics. And then the 2 combined together are the new data intelligence platform concept that Databricks has provided. So first, kind of table stakes, want to talk about unify and own the data. So with this architectural concept, we're proposing a lakehouse architecture. So this is something that Databricks developed in 2020, which is very popular currently. It proposes using cloud object storage as the main repository for all of your analytical data, and doing so in the agency or government cloud account. So no egress of data out to a SaaS provider or outside of the boundary which it controls, obviously improving the security posture of that data estate infrastructure, but also providing a much better cost model to some of the legacy storage models we've seen in the past. We're also proposing the use of an open storage format, whether that's Delta Lake or Iceberg. The two seem to be the market leaders right now. This too is highly strategic because it reduces the vendor lock-in that's very obvious and apparent right now in existing data silos. It also does not lock you into Databricks because there's an entire ecosystem of analytic tools that support both of these. And then in terms of Lakehouse principles for modernization, there's three I really want to drill down on. So the first is that as we build out the Lakehouse and build our ingest pipelines, we want to ensure that we're curating the data to offer trusted data as products. So in this environment, we want to ensure that we take the raw data from our transactional systems, enrich it, clean it, make sure it's high quality, and then potentially normalize it to improve the performance of any downstream analytics. The second principle I want to dive a little deeper in is adopt an organization-wide data governance strategy. I'll talk about that a little bit later, but essentially once we have our clean data, our high-quality data, we need a way to be able to enforce proper access controls. We need to be able to audit access to the data, and we need to always understand the data lineage. And then the third principle, which we'll talk about, is not only using the open storage format, but also using an open interface so that we can share both intra-agency as well as potentially across a wider part of mission partners. Okay. So if we look at the next core design principle, so we want to make governance a strategic asset. And this is necessary because for most public sector workflows, we're dealing with sensitive or highly confidential data. Okay, so there is the requirement not only to have strict control within our cloud infrastructure, but also access control, perhaps even fine-grained access control on the data itself. And then we need to be able to perform continuously, or we need to continuously monitor that access so we can ensure we have compliance. But we also need to democratize the data. There were at least two of the earlier executive orders or acts that talk to open collaboration, data sharing, making sure that not only data teams within the agency have access or appropriate access to the data, but we're able to share out data with appropriate access to a wider set of partners. So Databricks is solving this problem with Unity Catalog. So this is the governance layer that we're applying directly on top of our Lakehouse architecture and is giving us the best of both worlds. And from a feature perspective, we're providing governance on structured data, but we're also providing governance on any unstructured data. Think of form data that may be part of the intake process for your mission delivery, as well as governance directly on top of the AI functions or AI models that you may develop as a part of your Lakehouse. There's built-in auditing on all of this data, as well as the ability to apply the fine-grained access controls that we need. In addition, we can federate out to external data sources if we need to bring those in for analytics. Realistically, especially in the early stages of a Lakehouse implementation at IOC, we're not going to have all the data we need to perform our analytics. So we can federate out to those existing data silos to bring those in, govern them, and make them a part of our data estate. And then we can also provide through Delta sharing a means of giving secure access to the data that we have in the Lakehouse. We're also continually improving the product by integrating in artificial intelligence, two things I'd like to point out. The first is the ability to classify our data and AI assets. Examples of this being we can add a description automatically to a table or comments to columns. And this is obviously important for data teams. If they're searching for data, they want to be able to find the data sets that they need. When they find them, they want to understand at a column level what's in the table. But also as we build additional AI agents, the AI agents need that metadata to understand how to use the data. Okay, so it serves multiple functions there. We can have this auto classification done with AI, so we don't have to have our data stewards necessarily go in and manually write it all themselves. They can just act as the auditors of what's been provided. We also can auto-detect PII, so as a pipeline executes, have Unity Catalog through pattern recognition determine potentially if there's social security numbers or anything that may need to be obfuscated or have stricter role-based access control applied to it. Okay, and then this leads us to the ability to support multiple different versions of data mesh patterns, essentially agency as a domain. So we're seeing, obviously at the agency level, if the agency is the data domain, the ability for them to integrate into a wider mesh using delta sharing. We can have sub-agencies or programs within a department act as their own data domains, data stewards, and then share out data either intra-agency or to other mission partners. What's interesting about delta sharing is because it's an open protocol, we can do this within the same cloud region, we can do this across cloud regions within the same hyperscaler, or we can do this across cloud providers, say AWS to Azure. It's an open interface. Once we have the share defined, if the appropriate privilege via token is granted, that share can happen. What's also nice about this protocol is that there is a large ecosystem of tools that support it. So an external party that doesn't use Databricks can even be a part of the mesh as long as they're using a tool that supports the sharing protocol. This aligns nicely with the EO we talked about earlier, stopping waste, fraud, and abuse, because we can eliminate data silos to a certain extent, making unclassified data accessible via this type of pattern. Okay, and then finally, to drill down a little bit on how we can take this governed data estate and accelerate data-driven citizen services, the first feature of the platform that I'd like to talk about is Databricks AI BI. Two core components, obviously, dashboards, which give analysts the ability to visualize data sets, as well as Genie, right, which is a conversational agent built to give data teams the ability to ask natural language questions and get answers back, okay? So how does this work? From the dashboard perspective, I guess it's not rendering, or let me go back. Bear with me for the middle here. So from a dashboard perspective, so AI is integrated in three ways that I'd like to point out. So the first is to build the data set. We can use Databricks Assistant to use text to generate the SQL to build the data set that backs each visualization. At the dashboard level, we can similarly use an integrated agent to not only select the appropriate visualization, but also then configure it in the dashboarding template. And then once the dashboard is published, we can introduce different predictive analytics models to improve an analyst's understanding of the data. The example we're showing on the far right is the integration of a forecasting algorithm. So you can take that backing data set, then run the forecast on the data to predict out what the ensuing time periods are going to be from a result perspective. And then with Genie, three interesting things about this. So this is an agent system. It's comprised of a number of AI agents. It works, and it works really well because it can leverage context from Unity Catalog, right? That platform metadata we were talking about earlier. So not only are we telling it what tables to use as reference, but also it has all of that additional metadata so it can provide more accurate answers. And then when we build Genie space, we can put plain text instructions on the space to give it additional context, how to calculate revenue, how to determine certain answers that may not be intuitive based on just the tabular structure. So this is effectively a way to fine-tune the way Genie operates on the data, but in plain English. And then finally, as data teams are using Genie, there is the ability to incorporate feedback. So there's simple yes, no. If you haven't used it before, there's the simple, is this answer accurate, yes or no? So that feedback is incorporated, but you can also give additional context if the answer does not look accurate. So there's an iterative improvement cycle that's inherent to the way the agent system is implemented. So when we combine the two, we can really improve service delivery. This is a simple example, but when you build dashboards, right, it's almost impossible to anticipate all the questions that are going to be asked of the data. You do your best to represent the data in a way that's meaningful to the data teams, but there's obviously always additional questions. So with Genie integrated, we can short circuit the feedback loop or development loop that's required to get those questions answered. The analyst can simply ask a new question of the data sets that back the visualization and get that answer without necessarily having to have a development team get involved or an expert get involved to give them the answer. Okay, and then finally here to close out, I want to talk about agent systems and how we can support the development of these within a government environment. So as we've introduced the topic earlier, an agent system is simply an ensemble of AI agents that continuously learn your unique data and semantics. Okay, so Genie is a really good example of this. It's a number of AI agents, right? We've talked about how it has access to the data in your data estate via Unity Catalog, and then you're able to ask it questions, and then it receives feedback, remembers that, and improves itself, right? So this is something that's a part of the platform, but if an agency wanted to develop their own, we have Mosaic AI, which provides a full MLOps capability. So you have access to the data via Unity Catalog. You can develop, train, and test your own custom models if you want to do that, fine-tune them, put them into production with a model registry, so you have that option. You can also use proprietary LLMs. We give you access via a gateway to, say, an OpenAI to use their API. You can use open source LLMs that are deployed directly on our control plane. You can fine-tune those. We also support RAG architectures. So if you want to use a vector database, insert your own data into that vector database to quickly serve it to an AI agent, we support that type of architecture as well. So we're giving government a significant MLOps environment in which they can hopefully rapidly adopt both AI agents as well as agent systems to improve the delivery of citizen services. So closing thoughts, hopefully this was an interesting introduction to the way in which the Databricks data intelligence platform can be used to reinvent the way government uses data in AI. It wasn't very interactive, right? But now we have the opportunity through a fireside chat to listen to Asim lead a further discussion on the topic. So Asim, I'd like to invite you up.
Thank you, Eric.
Yeah. All right, good luck, guys.
Just want to start out with asking a quick question. What do you guys think is the most valuable natural resource that we have that we cannot live without? Anyone? Yes, sir. Time.
Good try.
Okay. So you don't need food, only time to live. Water. Who said water first? This is for you, ma'am. So water, right? So why water is important? And what happens to the water, guys? In other words, when we consume and we use water, what happens to it? And yes? goes to the water cycle. But what happens to that water? So when you are in the morning waking up, brushing your teeth, doing laundry, utensils, industries, manufacturing plants, what are they doing to the water? Yes, basically making it dirty, right? So it becomes wastewater. Awesome. So we all know that on this earth, it's 70% water, right? Everybody knows that. Do you know only 3% is fresh water out of 70%? And out of that 3%, 2% we cannot consume because it's the ice, the icebergs. And it's only 1% clean water that we are depending upon. They know that, didn't they? So that's why clean water is very important. And that's the mission of my organization, is clean water for future generations. And one more thought, I was just coming here and I'm like, I met this gentleman, we just exchanged the pleasantries, and he's like, what do you do? I'm like, I clean water. And he's like, what does that have to do with data? Why are you here? Should be in the wastewater conference.
Wait a minute. This is exactly what I was wondering. I was like, what are you talking about? Isn't this a data and AI summit? And why are we talking about water, Ricky? By the way, this is Ricky Arora from Minnesota Metro Council. Ricky runs their data and AI practice. And today, I know you're disappointed because we won't be after lunch presenting you with slides, but we'll tell you a story of a data transformation at a public utilities, and we'll walk you through the inception to where we are and see if you can actually grab some action items and things that you can leverage in your own transformation. Does that sound good?
Thank you.
Right.
Thank you.
So Ricky, let's take a step back, man. You need to get me a chance to get ready, so we're gonna have fun. Help me first, I guess, tell them a little bit about what does your organization do? I know you started on it. How is it organized? What does it do? And what is your mission? I know you talked about the mission, but how's it set up?
Sure. So again, folks, hello. I'm Ricky Arora. I'm from Minnesota. So I'm from Metropolitan Council Environmental Services. And Metropolitan Council, basically, it's a regional planning agency and a policy-making body. And it also provides essential services to the citizens of Minnesota. So our customers are citizens like you guys. We serve about 2.7 million people in about 111 communities. So think about like that wastewater that everybody is generating that's coming to our water resource recovery facilities to make it clean. Metropolitan Council has 5 divisions. I'm in the second largest division. The biggest division is the bus and light rail, so the transit division. Mine is environmental services, and we operate 9 water resource recovery facilities, so 9 treatment plants, and they are like all over the Twin City area, 7-county region, basically. We also have community development for affordable housing and planning. And the 4th one is transportation services, which is contracted services. And 5th one is the support division, basically, which is all departments like IT, centralized, procurement, HR, legal, so on and so forth. So they are the support division that supports all the other operating divisions of the council. Like I said, we have 9 wastewater treatment plants. And why is that important? Like, why? What does that have to do with data? And why am I here? And how did Databricks help us? Just to give you a context, in our 9 wastewater facilities, we have historians like a SCADA system, and I'll explain what that SCADA system is. But the data is generated from the wastewater treatment processes, like how we treat wastewater to make it clean water. And how does anybody know like how much, any guesses like how much wastewater do we treat every single day? Any number?
Any guesses?
No, we meaning in Minnesota, just focusing on, not the nation. How many?
A million.
Million gallons. Any other guesses?
A day?
Any other guesses? So we're talking about 2.7 million people.
We got somebody over there.
Yes. 200 million.
200 million and one.
Sold.
Yeah. So where's that star? So yes. So we treat 250 million gallons of water a day
Ricky?
from across. So there's the star for you. 200 million, right? Very close. So 250 is the answer. One of our facilities is 10th largest in the nation. It treats about 180 million gallons a day, and then other 8 utilities combined is about 250 million gallons a day.
So the volume is massive. So let's start the journey from, because water, obviously humanity has been consuming water since humanity has been on the planet and has been working somewhat. What needs to change? What is your biggest data challenge? What are you trying to change?
So we're trying to transform our Metropolitan Council Environmental Services Division to a data-driven decision-making utility so that we can monitor the processes that treat this wastewater to make it clean water, to manage them, optimize them, troubleshoot them. And then also at the same time, we are trying to make sure that the plant operations who do this operation are also reliable, efficient, cost-effective, and compliant. Because we are also very highly regulated by Minnesota Pollution Control Agency and EPA and whatnot. So there's a lot of state and local regulations, air permits, water permits, you name it. So we got to make sure that we don't violate anything because nobody wants to be in the newspapers for bad stuff. Good stuff is great, bad stuff is not. And we want to make sure that that doesn't happen. So compliance is a big deal for us as well. Also, like I said, we have 9 different locations where this water comes to. So water moves from these houses through city pipes, which are like 6-inch to 14 feet in diameter. You can run a truck through those pipes. And that water comes from, like I said, different locations to each of these 9 plants. And that's where this all data is residing right now in the historians that collect the data in real time, meaning we have sensors, and it's a real-time data that's being collected through a SCADA system so that, for example, if something is not right or depending upon what operators want to look at, they look at this HMI, human-machine interface, the visuals, and say, oh, I need to fix this, or I need to change the values. So all of that data and our data is huge, by the way. That's why I'm here. Our data is, so across all 9 plants, we have 120,000 instruments collecting data at 10-second resolution. So every 10 seconds, we get 120,000 records, every 10 seconds. There's 1,440 minutes in a day, right? Times this, times 365, times last 10 years of data. Don't even take out your calculators because it will show E. So anyway, so that's the amount of data that we have. The other big part is, so obviously we want to consolidate all of that data from different historians. And we want to integrate with other systems, like we have laboratory information management system, we have work order asset management system, we have PeopleSoft for our financials. All these disparate systems, and everybody controls their data. It's my data. You can't have it, right? It needs to be just looked at by me. Very common problem. So when we talk about democratized data this morning, all morning we've been hearing about that, well, somebody has to unlock that first. So our goal, like I said, of this transformation is no data left behind. We are going to bring all the data. And we started with the SCADA data for these treatment plants, basically. And we want to integrate, like I said, with lab data or other data sets that we have. But we also want to empower our end users, our stakeholders, process engineers, plant operations, safety specialists, compliance, you name it, all of them so that they have access, same access, and single version of truth of this data to everybody. That's the goal, right? So empower them with all of this data, and then also provide the tools. So when we empower them and we have consolidated this data in a single platform, Lakehouse platform, it just overcomes that data silos. The data silos don't exist. Again, we have not done it all, so we are on this journey, which I'll share where we are at now and how we got here. But it's a good process that we went through. And the last part also is that this lakehouse has all the tools that we need for data science, advanced analytics. So once the data is there, you have all the tools. Right now, our current state, for example, is a little bit different, which I know is your next question, though. Like, what are you doing right now? But before we get to that,
You're a mind reader.
I am. I just captured everything. But the idea, again, is to enable the decision-making using these tool sets that are embedded in the platform. So we don't have to go anywhere else for data discovery, for data exploration. All those things that we want, near real-time access to make these informed decisions.
Thank you, Ricky. So what I heard is the data volume is massive, data variety is massive. It's locked into proprietary systems right now, which is making accessibility and everything hard. And you're trying to decouple and liberate that data. Would that be correct?
Yes, exactly.
You also mentioned SCADA data a couple of times. Do you want to maybe,
Yeah.
I don't know what SCADA data, you guys know what SCADA data is?
So SCADA is the supervisory control data acquisition system. So that's the data from the field sensors that coming in real time. Like every 10 seconds, a value is sent from these 120,000 instruments. And SCADA system is capturing all of that. But then again, the question becomes, the data is growing, like I said, every 10 seconds. What do we do with it? How do we analyze it? Right now, our biggest challenge is we are only, with proprietary systems like SQL Server and other systems that we have in place, we are only able to get to 20% of our data. Our data is, we can't even process all of that data that's currently coming in. There's no capacity, there's no horsepower, processing power at all to do any of this stuff. The other part of this is, besides 20%, is that our data is something what we call as it's hydrated, meaning if the data value doesn't change, like for minute 1 or 10 second, we do not store that value every single time because we will run out of storage like every day otherwise. So we only store by exception. But what does that do then? What that does, the challenge is, well, when people ask for data to analyze or I want to troubleshoot, it's incomplete in their eyes. The data is not incomplete, right? It's just we didn't store every single value every 10 seconds because we couldn't, right? So that's the other bigger challenge for us. Like, how do we take that data, the dehydrated data, the SCADA data in this case, integrate with, like I said, other data in the plant from laboratory or safety systems? That's one challenge. But then hydrate it back, meaning fill in those values so that it becomes complete, so that a process engineer or operations, they don't have to take all of that data first and then hydrate it themselves before they can even start analyzing it, right? And the third piece is the analyzing of that data right now is siloed, meaning, oh, I got to take this data now, put it in a spreadsheet, or run my R script someplace else, or Python, and then do whatever. But then the question becomes, well, you have to be here in your office every single morning to press that button to make sure that your scripts are running. I think we all can connect to that. And then once your scripts run, then how do you make sure that everybody can access and visualize it on a common centralized place? SharePoint is one, but you still have to do a lot of manual effort to get to that point, right? So that's our current state.
Awesome. So we heard why you're changing. We heard the challenge that you're trying to solve for. We heard your current state. Now let's fast forward a little bit. I know we are already on this journey. What does that future looks like for you on a new data intelligence platform? The capabilities that you now have?
Sure.
And what does that look like? If you can describe that briefly.
So for us, it's been awesome because we are initially right now in a state where we are implementing the very flexible Lakehouse platform and the medallion architecture. So all these historians and the SCADA data, all that jargon that I just mentioned, we are taking all that dehydrated, right? That exception-based data, grabbing it from all these historians, 100% of the data now, not just 20%, right? 100% of the data, putting it into the bronze layer in the medallion architecture. In the silver layer, that's where we hydrate that data. That's where we QA, QC it. That's where we make sure that those gaps they're no longer gaps. It's a continuous time series data every 10 seconds that exists. From there, the next is the goal layer. So we go take the data to the goal layer. That's where all the aggregations happen. 10-second data to minutely values to hourly, daily, monthly, weekly. It's pre-aggregated and it's stored in the goal layer. Again, 100% of the data, not 20%. We solved that problem of it's not exception-based anymore. All we need to bring in now is unleash that data and bring all the stakeholders onto the platform so they can start utilizing the data, do the analysis, and make sure that they are also, there's data governance, because obviously we are using Unity Catalog to make sure that roles and responsibilities and how data is shared, that exists. And then at the same time, we also make sure that the built-in tools, so rather than exporting that data from that medallion architecture on the Lakehouse platform to a spreadsheet and then doing all of those things, why don't you just do all of that Python and R scripting and right on the Lakehouse platform? And at that time, then once it's done, you can visualize that on a dashboard. It's just all right there in one place, one central consolidated place.
That sounds a lot of fun, but if I am a business owner, and obviously, everything requires money and effort, what is the business impact? What is the return on investment? Why would council continue to invest in this? So this is all great, right? You have a great vision, but where's the beef?
Fun is literally a lot of fun, because when you're dealing with this kind of data, and then when you take that data and then cater to your end users, and it becomes an eye-opener for them, that's a great feeling. That's a very much fun feeling, like satisfied feeling when you see them, like, whoa, how did you get that? I'm like, don't worry about that, just use it, do what you need to do, that you're good at. You don't have to do that other steps. But for us, the benefit has been the operational efficiencies, big time. Increased productivity, because again, we are not doing that siloed tools anymore. So data is just there, you start using it. Innovation. So that's when all the communication has started happening back and forth. So I just got an email, like I said, we are just on this journey. So one of the plant managers is like, well, I want to see this chemical optimization, and I want to see how that chemicals balance out with the safety, because these are dangerous chemicals and there's thresholds, so should I lower or make those thresholds go high? Safety is like, oh, lower it or go high. And she's like, no, it has to be a balance. But guess what? We don't even have that data available for them to have this debate, because right now it's sitting in those historians. And we couldn't bring that because we could only bring that 20% of the data, like I said earlier. So these kinds of efficiencies is what, now unfortunately we have 9 plants. So 6 plants data, massive, again it's like hundreds of terabytes of data is already in the Lakehouse Databricks platform in the medallion architecture, but her plant is not yet. So I couldn't tell her like, hey, go to this and we can just, it's all there. So again, it's coming. So operational efficiency is number 1. The second big thing is the data analytics and the human AI collaboration. We talked about Genie rooms, we heard about all of them. So not all process engineers or operations are like people who know R or Python, right? So we are trying to build those Genie rooms in such a way that, again, simple plain English questions. Hey, what's my influent flow data from plant XYZ for last 3 months? And Genie room just shows you a chart, and you can export that data.
So basically you're saying you're empowering your business users.
Empowerment is a big one, but when we put in the AI, and then AI identifies those patterns and have the power to do this multi-terabytes of data processing, but the domain knowledge exists with the subject matter experts. So when you combine the two, that's where the magic is happening.
Awesome. I know we got less than 1 minute. Any parting thoughts?
I think the parting thought is like, we started with a very small pilot, and when Databricks and Asim in this case came to us, he's like, oh, we can help you. I'm like, what are you gonna help with? He's like, well, what's your use case? And I'm like, okay, here's chemical optimization. He's like, no, give me something big. I'm like, okay, here's 2 use cases. And he's like, no, you gotta dream big, think big, not just use cases. And I was like getting upset, like, what the heck does this mean? Because I'm like, okay, here's our SQL server, make it faster. He's like, I'm not here to take your SQL server and make it run faster. No. So then we came up with a journey with him where, it's not just a technological change, but it's more like a strategic evolution because like our goal is no data left behind, right? So in his case, he helped me see like, oh, you got to dream big, think big, meaning bring all your data. What's holding you back? I'm like, are you sure that you can handle like, so many hundreds of terabytes of data at 10-second resolution? He's like, yeah, I think so. I'm like, I don't think so. He's like, oh, yeah, we can do it. It's like, no. Anyway, so that's the parting thoughts. Like, we started with a very small pilot, and it was so successful, and our leadership is so happy. And we haven't even given these tools yet because we are on this journey as we speak. I mean, we are processing all this data even right now behind the scenes. But there's so much excitement about the lakehouse architecture, the availability of these analytical tools to be able to do data science on them and whatnot, that it's just so magical, and people are like looking forward to all of this adoption, and they can't wait until we have all the 9 plants integrated with all the other plant information management systems we have to make that story complete.
Thank you, Ricky. I know we are out of time, so we'll be here if you have any questions, but big round of applause for Ricky, please.
Thank you, guys.